two particles on opposite ends of the universe. You change one, the other responds instantly. Not almost instantly, instantly, faster than light could ever travel between them. This isn't science fiction, it's quantum entanglement, and it might mean reality itself is fundamentally different than what you've been told. Einstein called it spooky action at a distance. He hated it. He thought it proved quantum mechanics was incomplete. But here's the thing. Einstein was wrong. And what that means for the nature of reality will change how you see everything. Let's start simple. Quantum entanglement happens when two particles become linked, not physically connected, linked in a way that defies our everyday understanding of cause and effect. Imagine you have two coins. Normal coins work independently. You flip one in New York, your friend flips one in Tokyo. The results are random and separate, but entangled particles don't work that way. When particles become entangled, measuring one instantly determines the state of the other. No matter how far apart they are, you measure one particle spinning up, the other will be spinning down. Always, instantly. This has been proven in labs thousands of times. It's not theoretical anymore, it's observational fact. Einstein's problem wasn't that entanglement seemed weird. His problem was deeper. Special relativity says nothing can travel faster than light. Information, energy, influence, nothing. But entanglement seemed to violate this. If measuring one particle instantly affects another, information must be traveling faster than light, right? Einstein thought this meant quantum mechanics was missing something. Hidden variables, some underlying mechanism we couldn't see yet. He spent decades trying to prove it. In 1935, he published a famous paper with two colleagues, the EPR paradox. It was meant to show quantum mechanics was incomplete. But Einstein made one crucial assumption. He assumed locality. The idea that objects are only influenced by their immediate surroundings, that the universe is made of separate, independent pieces. For decades, Einstein's challenge stood. Then, in 1964, physicist John Bell published a theorem. Bell's theorem showed something revolutionary. If hidden variables existed, they would produce specific statistical patterns. You could design an experiment to test whether those patterns appear. In the 1980s, physicist Alain Aspect actually did the experiment. He entangled photons, sent them flying in opposite directions, measured them before any signal could travel between them. The results were clear. The particles violated Bell's inequality. Hidden variables were ruled out. Einstein's assumption of locality was wrong. The universe isn't made of separate, independent pieces. At the quantum level, reality is fundamentally interconnected, and that changes everything. So what does non-locality actually mean? It means the universe doesn't work like a collection of separate objects. At the deepest level, everything is connected, not metaphorically, physically, through quantum entanglement. Think about it this way. You assume your phone is separate from the moon, and in everyday life, that's fine. But at the quantum level, particles in your phone were once entangled with particles across the cosmos. The Big Bang entangled everything. As the universe expanded, those connections stretched, but never broke. You are made of particles that were once intimately connected to particles in distant galaxies. Those connections still exist. They're just harder to detect because warm, complex systems like your body lose quantum coherence quickly. But the connection is real. Locality is an illusion created by decoherence. Here's where it gets stranger. Entangled particles exist in superposition, both states at once, until you measure them. When you measure particle A, it collapses into a definite state, and particle B instantly collapses into the opposite state. But here's the question. How does particle B know? No signal travels between them. Nothing physical connects them. Yet B responds instantly to what happens to A. Some physicists say the particles were never truly separate. They're part of one quantum system, one wave function that spans space. When you measure any part of it, the entire system updates. Others say the universe splits. Many worlds interpretation. Measuring A creates branching realities. In one branch, A is up and B is down. In another branch, it's reversed. You just see one branch, but both exist. You might think this is all abstract philosophy, but entanglement is already changing technology. Quantum computers use entanglement to perform calculations impossible for classical computers. By entangling qubits, they process multiple possibilities simultaneously. Problems that would take normal computers billions of years can be solved in minutes. Quantum cryptography uses entanglement to create unbreakable codes. Any attempt to intercept the message breaks the entanglement. The eavesdropping is instantly detected. China already has a quantum satellite. They've sent entangled photons between ground stations thousands of kilometers apart. The quantum internet is coming, and it's going to make current encryption look like a child's lock. But the real question isn't about technology, it's about what entanglement reveals about the nature of existence. If particles that have never interacted can be correlated, if distance doesn't matter, if the universe updates globally and instantly, then space itself might be an illusion. Some physicists think space emerges from entanglement, that the three dimensions you move through are byproducts of quantum connections. The universe isn't happening in space. Space is happening in the universe. This matches what we see in black holes. Information that falls into a black hole becomes entangled with the radiation coming out. Space and entanglement are deeply connected, maybe fundamentally the same thing. We think of ourselves as separate beings in separate locations. But quantum mechanics suggests something different. At the most fundamental level, separation might not exist at all. Quantum entanglement isn't just a weird quirk of tiny particles. It's a window into the fundamental structure of reality. It tells us the universe is non-local, interconnected in ways we're only beginning to understand. Einstein was right to be uncomfortable. Entanglement violates our intuitions about cause and effect, about distance and separation. But reality doesn't care about our intuitions, and the more we study entanglement, the stranger reality becomes. We live in a universe where everything is connected to everything else, where the act of observation shapes what we see, where space itself might be an emergent property of quantum information. That's not just physics. That's a fundamental reimagining of what existence means. The implications are still unfolding, and we're probably just scratching the surface. If this changed how you see reality, you know what to do.